SwayamPrabha. Digital India. Educated India. SwayamPrabha. Digital India. Educated India.
Let us look at some additional topics related to airline fleet planning, mostly related to the performance related matters. First, we need to understand that when we look at an airline operation, even the term performance has different connotations. There are various types of performance as related to a transport aircraft. The first of these terms is nominal performance, which is the average performance level of a fresh aircraft as supplied by a manufacturer to the operator. So, this particular nominal performance data also includes some performance improvements which are expected to come in the near future. They are in the pipeline as far as the manufacturer is concerned. Let us appreciate that aircraft manufacturers are not static. They continuously improve their products, and therefore, the performance of the aircraft is not remaining the same throughout its life. There are certain improvements which are brought in by the manufacturer, and also there are certain deteriorations which take place in service, because of which the actual performance may not exactly match with the performance that is given in the nominal performance data. Then there is a performance that is established in the Flight Crew Operating Manual FCOM. This particular data is the certified performance which is used by an airline or the flight crew for all operational calculations. Okay. So, remember that every aircraft comes with options on the power plant. It is not necessary that a particular airframe will have only one particular power plant associated with it. There could be multiple options available, and depending on the airline's choice, they can decide to fit the aircraft with various different types of power plant. Therefore, the FCOM performance normally is issued for each aircraft and engine combination. Then the third and the most important term is guaranteed performance, something that a manufacturer guarantees to the airline or the operator, because this is to ensure that the risks of the airline are offset. It should not happen that the performance that is proposed or offered by a manufacturer, if it falls short in real life, then the airline may not be able to operate a particular route safely. So, therefore, there is something called as guaranteed performance, and important point is that in case the aircraft does not give that performance in real life operation, then there is a penalty clause for non-compliance included. In other words, if the performance of the aircraft in actual service falls short of the guaranteed performance, for example, the takeoff distance required, for example, the landing distance required, for example, the consumption during cruise, for example, the cruise speed, if the published data is not matching with the actual observed performance, there could be some penalty clauses, because the airline has purchased the aircraft assuming that this kind of performance will be available. So, the guaranteed performance is the most critical performance level which the manufacturer guarantees. The FCOM performance is something that is specifically applied to aircraft and engine combination, and nominal performance is something that the manufacturer mentions with possible improvements over its service life. So, let us look at how these two types of performances basically are related and what is done. So, if you look at critical performance, there are these parameters. So, when we calculate the critical performance of the aircraft, we assume the aircraft to be full with 100% load factor. We assume that the payload is also full with the maximum certified payload. We assume that the cargo is also completely full, and we assume that the ambient wind and the outside air temperature, abbreviated as OAT, is about 85 percentile. So, you look at the data over a large period of time and then you pick up the ambient wind and OAT, that is almost always present around 85% of the times. With this particular assumption, we calculate the critical performance. But if you want to calculate the average performance, that is essentially to demonstrate the ability of the aircraft or the capabilities of the aircraft in average operating conditions. So, there we assume the load factor to be 75% both for the passenger as well as for the payload. We assume that only half the cargo is carried and the winds are within 50 percentile. So, when the critical performance is mentioned, we assume the most critical conditions, and when the average performance is mentioned, we use these average conditions. Let us have a look at what is the effect of the en route conditions on the performance of an aircraft. So, one very common occurrence is that the outside air temperature may increase above the standard ISA conditions. So, as the OAT increases, the engine performance goes down and the climb rate of the aircraft also is reduced. Okay. So, a very rough idea is that suppose you have a 10 degrees increase in the outside air temperature at the operating altitude of 33,000 feet, then effectively the aircraft has to climb to a height of 34,300 feet. So, the notional increase in the altitude to be climbed is 1,300 feet. In other words, the energy required by the aircraft when it operates at an altitude of 33,000 feet in a condition when the outside air temperature is 10 degrees more than the nominal value as specified by the ISA table, it is equivalent to expecting the aircraft to climb to a height of 34,300 feet. Okay. Now, during climb also there are issues. So, as the ambient velocity increases during the climb, the angle of attack during climb, which is alpha climb, and the flight path angle, these two angles are a bit different. Okay. So, the flight path angle is the angle of the aircraft as related to the flight profile, and the alpha climb is the net angle at which the aircraft is climbing. Both of them increase. So, you have to climb at a higher angle, and when you climb at a higher angle, then the distance required in the ground to complete the climb also increases. So, that means the climb will take longer if the ambient velocity increases. During cruise, you have either headwind or tailwind. Headwind means the air is coming against the aircraft at some relative speed. So, as the headwind increases, you have higher fuel consumption, okay, and also you fly slower compared to what appears to the ground. In other words, if an aircraft is flying at an actual cruise speed of say 400 nautical miles per hour or 400 knots, and it faces a headwind of say 10 knots, effectively you are flying with respect to the ground only at 390 knots. So, therefore, the ground speed will reduce. So, that is why we define something called as the equivalent still air distance to take into consideration the effect of presence of headwind or tailwind during the cruise. So, the equivalent still air distance is nothing but the ground distance travelled by the aircraft when there is no headwind or no tailwind, it will be 0 wind conditions. The formula for estimating the ESAD is very straightforward. You multiply the true airspeed with the actual ground distance and divide it by the true airspeed plus or minus the wind. So, if we have a headwind, we will use the minus sign. If we use a tailwind, we will use the plus sign. So, in this formula, TAS stands for the true airspeed and GD stands for the ground distance. As an example, suppose we have an aircraft that is cruising at a true airspeed of 500 knots and the ground distance is 2000 nautical miles. Suppose this aircraft is continuously facing a headwind of 40 knots, then the ESAD will be 500 into 2000 divided by 500 minus 40, which is 460, and the answer will be 2174 nautical miles. So, in a way, practically speaking, it would have travelled to 174 nautical miles extra if there was no headwind. That is why we define the term equivalent still air distance. Let us look at a very interesting term called as the specific air range or SAR, which is a very important parameter, especially when you are comparing two aircraft for their cruise performance, or when you look at even the same aircraft, how its specific air range changes. So, the definition of SAR is the distance flown by the aircraft per unit amount of fuel, normally expressed in nautical miles travelled per kilograms of fuel. So, it depends on various factors, like it depends on how heavy is the aircraft during the cruise. It also depends upon at what altitude you are cruising and at what Mach number you are cruising. All of these parameters and also the ambient weather conditions, they determine the specific air range. So, let us see the effect of Mach number at a specific altitude, at a specific weight on the specific air range. So, if you have an aircraft at low weight condition, then you can see the lines are almost parallel moving towards high weight. So, therefore, if the maximum point of these graphs is the maximum range cruise condition. Okay. So, if you want to obtain the maximum range in cruise conditions, okay, then you have to fly at that particular combination, because there the curve has a peak, and as you can see the Mach number for maximum range cruise increases as the aircraft becomes heavier. So, a lighter aircraft obtains maximum cruise range at a lower Mach number compared to a heavier aircraft. Of course, all this assumes that the cruising altitude and the outside air temperature is the same in all the conditions. So, there is also a concept of long range cruise or LRC. This particular concept is as follows. So, you take the condition or you look at the condition for MRC, you have a particular specific air range. What you do is find out how much is the improvement in the Mach number that I can get if I reduce or compromise on the MRC by 1%. If I am able to accept 1% reduction in the specific air range, I will get some improvement in the Mach number, that is usually of the order of around 5%. Okay. So, if a heavier aircraft can also fly at a higher Mach number, that is better, because then you will reduce the time required. So, this is the concept of long range cruise. So, the LRC is obtained corresponds to the Mach number which gives you 1% lower specific air range compared to the MRC. So, MRC and LRC, there is a very important and interesting trade off between the two. MRC definitely is the most efficient cruise because it gives you the higher specific air range at each weight. So, when you are only critical about the fuel consumption in cruise, then MRC is the recommended condition, but it is very difficult to maintain, because to maintain this you need to constantly adjust the thrust to ensure that you are generating the right amount of thrust to maintain the Mach number. Okay. Now, LRC is the trade off. Aircraft are meant to fly from destination A to B, and the passengers are not necessarily concerned too much about the operating efficiency of the airline, they are concerned about getting there fast. So, if you want to have a trade off in fuel efficiency and the speed, then you use the LRC. This is the most usual strategy followed by the airlines during cruise, okay, because LRC gives you a stable cruise flight without any need for the pilot to constantly adjust the thrust. Why is it so? Because suppose we reduce the speed of the aircraft flying at LRC. So, when you reduce the speed of the aircraft, the drag will reduce. As the drag reduced, the speed is automatically maintained. On the other hand, suppose we increase the speed from the long range cruise speed, the drag will increase. As the drag increases, the speed of the aircraft will automatically reduce. So, without any great thrust adjustments by the pilot, one can maintain LRC, and also a trade off between efficiency in operation or fuel efficiency and time required for the flight because of higher Mach number. LRC is normally preferred. There is also another option which is called as a minimum time cruise. So, what is the definition of minimum time cruise? This is the Mach number to fly at which the total trip time is minimized. Okay. Now, when is it done? Generally MTC is generally done when you are already recovering from a previous delay and you want to reach the destination faster, because otherwise the connecting passengers might lose their connections. Okay. So, that is why to allow connections at the hub airports, we sometimes compromise on fuel efficiency and go for the minimum time cruise. So, as you can see, the graph on the right hand side shows you the MRC and the LRC, which we have already discussed. Another thing can be the minimum time. So, that can be higher Mach number compared to even the Mach number for LRC. Many a times the airline does not look at only the operating cost or fuel minimization, they look at total cost. So, let us see total cost consideration. So, when you are bothered about only the minimization of the fuel cost, then you will fly at the MRC, because the trip cost is going to be the lowest when you fly at MRC if fuel cost is the only consideration. However, as we have seen, flying at MRC means you fly at a lower speed. Now, if you look at certain fixed costs of the aircraft, they are fixed, they do not depend upon the speed at which you fly. Then there are some time related costs. These are going to reduce as your speed is increased, because you will have less time. For example, the allowances paid to the pilot based on the hours of flight. For short haul routes it may not matter, but for long haul routes, when you have 8-hour flights, there can be a substantial difference between the time cost related to low speed flight and the high speed flight. So, in general, as the cruise speed or Mach number increases, you will have lower time related costs. So, then if you add these two costs, the fuel cost and time cost, you get a curve which gives you the minimum total cost, and that may have a different minimum as compared to the MRC. So, that is called as the economical operating speed. Okay. So, there are various cruise strategies as we have seen. There is this MRC, when you look only at minimizing the fuel consumption by maximizing the specific air range. You have the LRC, where you agree for 1% compromise on the SAR to get better cruise Mach numbers or higher cruise Mach numbers. There is also a minimum time cruise, where the whole aim or focus is to fly such that you can have the fastest flight, but not necessarily at such a high Mach number that your SAR becomes very poor. And then you have the cost index condition, where you look at all the costs, time related costs, fixed costs and fuel costs, and then get the optimum operating Mach number. Let us also now look at how an alternate airport is selected. It could be one airport or it could be many airports. So, first of all, we need to have in mind some alternates, because it may not be possible for us to land at the desired destination airport. Why is it not possible? There could be many reasons. One common reason is poor weather conditions prevalent at the destination airport. Then it is possible that there are some obstructions on the runway, because of which the airport is temporarily unavailable. So, therefore, when you come in to land at an airport, your destination airport, you may not be permitted to land because the runway that is assigned to you is not available. So, it is very important to select the alternate airport correctly and appropriately, because you can have a lot of operational issues if you do not do it properly. Moreover, the selection of the airport, which airport is correct as an alternate airport, depends on weather. It should not be located at a location where the weather is very similar to the weather in the destination airport, because if you are diverted because of weather conditions from New Delhi, for example, and if you choose Lucknow as the airport, maybe the weathers are very similar. So, the chances of diversion again from Lucknow will be very high. This could be an example. It depends upon the geography, it depends upon are there any terrain related constraints. It should not happen that when you divert from the destination airport, your alternate airport is at a very inconvenient location, it has a very small runway, it has got a high altitude. So, therefore, there will be more difficulty. So, geography of the area is very important. Also, there should be the presence of airfields nearby, right. You cannot simply land anywhere, you need to have an airfield which is capable of handling your aircraft. It should have the facilities you need, it should have the runway length that you require for the operating conditions under which you are operating. If the airport is too nearby, as I mentioned, there will be similar weather conditions. If it is too far away, it may be suitable, but then you have to carry lot of fuel to go to the alternate, because of which you may encounter the maximum landing weight limits on the range payload diagram, as we discussed earlier. By the time you come to land, you may have a landing weight more than what is permitted, or you may have to compromise on the payload, because now you have to have more fuel to go to the alternate. So, you have to be very judicious in your choice of the alternate aerodrome. So, the rule of thumb is that generally the alternate airport is generally taken to be between 150 to 250 nautical miles away from the destination. This is the kind of a range. Many a times this range is specified in the regulatory documents, but of course, every flight plan there has to be an approval, and therefore, if you indicate in the flight plan the alternate and if it is approved, then you are clear about it. All aircraft have to carry reserve fuel, which is more than the fuel required to do the intended mission. Okay. Why do we have to carry reserve fuel? There are many reasons. First of all, the aircraft performance may not match exactly with the actual performance, even guaranteed performance, because of certain changes, certain issues, certain modifications which have been made by the manufacturer. There could be errors in navigation. Even though we have very sophisticated instruments on the aircraft, but all of them are prone to errors, all of them are prone to disturbances. So, therefore, especially in a long distance route, and that too routes which are not properly covered with the sophisticated navigation aids, where you do navigation based on certain primitive techniques, there could be higher navigation errors. Your location will get corrected eventually, but you would have deviated and gone far away and you consumed extra fuel in that case. The other possibility is that when you plan your journey, you file a flight plan, you have certain plan in mind, but when you actually travel, you might encounter en route weather conditions, because of which you may have to circumvent that area. I remember I was on a flight once from Kolkata to Mumbai, and we were told by the pilot during the flight that there is very bad weather over Ranchi, because of which we have to take a circuitous path to avoid the bad weather. These kind of deviations normally happen because of bad weather situation. Sometimes there may be an air show going on or some other activity going on, due to which a particular area is not available for commercial flight. The airspace is closed or temporarily not permitted. You may have to take a circuitous path. All these are required. If you know a priori about the non-availability of a particular zone, then of course you will plan for it in the flight plan. But sometimes these things get known too late. So therefore, there could be these reasons, due to which, and the most common condition as I mentioned is the en route weather conditions. All of this leads to the requirement for reserve fuel, but how much fuel to carry, that is based on the operational policies of the airlines. So generally all airlines carry a particular percentage of the trip fuel or the mission time as the reserve fuel. It ranges from 8% to 10% to even 15%. But remember, all airlines would like to minimize the reserve fuel, because it is almost like a dead weight which is being carried, and if you do not have to carry that dead weight, you can actually carry more payload or cargo. So therefore, this is something that the airline would like to minimize, however, not at the cost of safety. So let us look at the one of the ways in which the regulatory bodies give some kind of concessions. So I have taken an example of the European Union Ops Operations Fuel Policy, called as the AMC Ops 1.255. So assume that there is one airport at the origin and one at destination, and assume that you are looking at the distance between the two is DOD, right. Then you have to identify an alternate airport, right, on the en route, where you will divert in case of any issue, right. So now the reserve fuel to be carried is specified as 5% of the total fuel, or it can be 3% of total fuel, provided there are certain conditions met. What are these conditions? The radius of the location of this alternate has to be not more than 20% of the total distance, and also the location of the destination and the alternate should be within some limits. Okay. These limits could be 25% of the DOD or 20% of DOD plus 50 nautical miles, whichever is more. Another way or another option is to just specify that the reserve fuel will be such that you can have 20 minutes of extra flight time or 50 minutes at the destination. Diversion. Diversion is something that no one likes, neither the airline likes it, nor the crew likes it, nor the passengers like it, but this can be sometimes enforced. What is diversion? Diversion means that you are not able to land at the planned destination airport. There are certain reasons for it, some of them are very common reasons and some of them are very uncommon reasons, but they are there. Amongst the common reasons, the most significant and the most prevalent reason for diversion is poor weather, which generally will result to poor visibility at the destination airport. Therefore, the aircraft is not able to operate safely. The other reason that is quite common is if there is a medical issue on board, either with the passengers or with the crew members, that cannot be handled by the crew members and it is a medical emergency. So you have to quickly divert, land, so that the passenger's life is not at danger. The third possibility is the technical issues with the aircraft. There can be sometimes some issues because of which the aircraft is either going to come back to the origin or discard the flight path and go to some divert to some other airport and take care of the technical problem. So during flight sometimes you have a minimum equipment list with which you are allowed to fly, and if that MEL is working on the ground, but during flight it becomes inoperational, some item becomes inoperational, then you are not able to operate safely. So, you have to immediately divert. So, this is also one common issue. So, these three, weather, medical and technical, are common reasons for diversion. But curiously, there are also some very uncommon reasons. Something that happens once in a while but does happen is diversion because of passenger disruption. There could be some rowdy passengers in the aircraft, they will create a threat to the safety of the crew members or the aircraft. Someone will just get up and try to open the door during the flight, or someone will start doing some unruly behavior. Then also the aircraft is sometimes diverted, and of course, there is a stringent action taken against the passenger. There could be obstructions at the airport. Okay. There could be a situation that the destination airport is having some stray animals. There is an aircraft which is stranded because it had crash landed in the previous flight, and it will take time for us to remove it. There could be a vehicle, ground moving vehicle, which has stalled, or there is a problem, it is stuck. Okay. So, or it can also happen that the airport is being cleaned of the snow or any other obstructions, because of which you may have to divert. And then there are emergencies. There are airport closures, sometimes because of strike of the crew members on the ground, terrorist attacks, hijacked aircraft, because that fellow has to be given priority. So, one example of this is what happened after 9/11 in the US. The whole US airspace was shut down. So, everyone had to be diverted, right. So, these are some of the common and uncommon reasons for diversion of the aircraft during flight. Another important thing we have to keep in mind is, in normal flight operations, sometimes you may not be asked to divert, airport is usable, airport is functional, there is no issue on the ground, except that unfortunately you are not able to land immediately when you arrive at the destination airport. One main reason for this is traffic congestion at the destination airport. Busy airports commonly have many aircraft coming in and landing. To optimize the operations, we work out some schedule by which maximum aircraft can be accommodated, but all aircraft are subject to atmospheric disturbances, operational issues, and therefore, they will never arrive at the exact time at which they were planned to arrive. So, because of that, now the ground facilities are going to be congested. So, you cannot simply allow everyone. So, what you do? The other reason is poor weather, but this is not because of continuous poor weather, this is because of temporary poor weather, which the ATC feels that will clear very soon and allow the aircraft to land. The other thing is runway unavailability, as I said, during snow removal or emergency. So, generally all aircraft are supposed to carry 30 minutes or 45 minutes of fuel to operate over an airport without landing, just circling in a particular path, and whether 30 minutes or 45 minutes or more depends upon the expected traffic and the past experience. Based on the experience, an airline might say, oh, when we land at Mumbai airport at this time, we almost always encounter a hold. So, instead of 45 minutes, let us budget for 50 minutes, 1 hour. It is a discussion of the airline operational department. Okay. Remember that when you are in a hold condition, at that time you are completely concerned about fuel consumption and fuel consumption only, because you would like to be up in the air for maximum number of time on the given amount of fuel. So, you fly the aircraft in the minimum drag configuration, which gives you the minimized fuel burn. Okay. And there is a particular manner in which a hold is conducted. For example, the red dot that you see in this figure is some navigational fix at the airport. So, the aircraft which are approaching the airport and are asked to hold, they will actually go towards this fix and then follow this particular kind of a right hand circuit and continuously fly in this pattern. Okay. If there are many aircraft, they may be stacked one over the other with some altitude difference, and they may all be doing these flights in a continuous stack. Okay. So, this is how the distance of this stack and its length, etc., it is all pre-decided and it is known. It is available to the pilot in the navigation charts. So, roughly about 4 minutes are taken by a typical aircraft to do one particular round. So, you keep on flying in circles like this or in oblong circles like this. And one very interesting operational scenario is when you are operating to an island in the middle of nowhere. So, the reserve that you carry when you operate to an island, they are called as island reserves. They are far more than the reserves used for a normal operation. Let me give you an example. So, it is very critical if you operate to an island as a destination, it is very important that you plan the operations carefully, because if in case there is a problem, there is no alternate airport nearby, you may have to actually come back to the origin or you have to go to a location far away, and therefore, very accurate weather forecasts and continuous monitoring is required more critically when you operate to an island. Let me give you an example. So, generally what we do is, generally when we are flying to an island airport which is in the middle of nowhere, you have to have reserve fuel for at least 2 hours of additional flight. Here is an example. This is the Indian Ocean, the territory which is located below India with Indonesia and Australia, and in this Indian Ocean there is one island airport which is IATA name is CCK, and that is basically the Cocos Keeling Islands. This is around 600 nautical miles from Jakarta, from the Indonesian border, and it is coming under the sovereign territory of Australia. If you look at this island, it is very interesting. Coco or Keeling Islands are basically a group of islands located, and there is one airport with a single runway located at the bottom left island. This is how it looks when you look at it from here. Very beautiful location, very popular among tourists, okay, very popular among tourists, and served by one airport located at this position. If we zoom further, this is how the airport looks like. Now imagine, in case you are coming in to land at this airport, and if you find that you are not able to land, then where are you? In the middle of the sea. So, you need to have fuel for minimum 2 hours of flight. Let us move on to a very interesting concept, which is a concept of reclearance, primarily used by airlines to reduce the amount of reserve fuel to be carried. As I mentioned, reserve fuel is something that is required only for emergencies, and all airlines would like to reduce the amount of reserve fuel that they carry, because it is a dead weight which may not be used, and generally it is not used, but you need to carry it for emergencies. So, you have to carry fuel to a destination and then fuel for a diversion. So, the operational agencies have given some concession. Okay. So, the aim of reclearance is to reduce the amount of reserve fuel to be carried, because today we have very accurate weather forecasting available, and especially in locations where the weather conditions are generally excellent and not known to be very bad, why should you really carry so much reserve fuel? So, assume that the original profile to be operated by the aircraft is to start from A, fly at a particular cruise altitude and then land at destination B, but you need to carry some fuel to divert to an alternate E. So, the original profile is from A to B with reserve fuel, let us say 5%, and alternate will be the E airport. Now, there is something called as the reclearance profile. In the reclearance profile, what you do is you introduce some phantom destination. This is an airport which may not be the actual destination, the destination is actually B, but you file the flight plan for a phantom destination C and reserve fuel to go from C to C1, whereas actually you want to go from A to B and then from B to any other alternate airport. Okay. So, what you do in this is you keep on flying till a particular reclearance point. At that point you have a look at what has happened so far. If you find that you have not consumed the fuel that you have carried extra, you can use the remaining part of the reserve fuel to actually travel toward the destination B and also have the fuel for the alternate. So, what we do is, in the reclassification profile, you file a flight plan saying that you land at phantom destination C and you carry reserve fuel for flight from A to C and C to C1 alternate diversion. Now, interestingly, if you look at the two scenarios, so let us say the trip fuel from A to C, which is in the reclassification. So, this is the trip fuel to be carried from A to C plus 5% of allowance from A to C, okay, plus diversions from C to C1. This is one scenario. You add these numbers. If these numbers are equal to the trip fuel from A to B, 5% of allowance from D to B, which is the reclearance point to B, and the diversion from B to B1, then if these two are equal, you could end up carrying lower amount of fuel as a reserve fuel. So, this is a very common strategy used by airlines if you want to fly a longer range mission, but you do not have the fuel capacity for mentioning that and then giving the reserve. You can do this kind of a shortcut, and it is approved by the regulatory bodies. It is done regularly. Another interesting aspect in airline operations is called tankering. What is tankering? In tankering, we do not carry less amount of fuel, we carry more amount of fuel than needed. Why tankering? So, in tankering we do not refuel the aircraft at the destination airport. Why? Because it might be possible that the kind of fuel you need is not available at that airport, or you want to reduce the turnaround time in multi-leg flights, because filling of fuel in the aircraft is one of the large components of turnaround time, and if you do not have the requirement to refuel, you can quickly turn around. This is very common in commuter aircraft which fly from A to B, B to C, C to D, multi-leg elements, and then come back to the origin. They have a reasonably good fuel capacity to go a long distance, but they are being used by the airline for multiple short legs. So, they have enough fuel for all the legs. So, they will fly with fuel for all the legs and then do not refuel at each destination. And another reason could be that there may be fuel supply available at the destination airport, but it is much more costly than your origin or some other airport. So, you do not want to buy fuel at a costly rate. So, therefore, you carry additional fuel, or you uplift the fuel at a destination or at a location where it is much less expensive. So, you have to strike an economical balance, because if you carry extra fuel, you are definitely going to consume more fuel. So, you have to look at the difference in the price of the fuel between the origin and destination. You have to also look at how much payload is being surrendered because you are carrying more fuel, and also you have to look at how much is the cost of the fuel that you burn additional because you are carrying a heavier aircraft. So, it is a very interesting research problem, and several projects have been done. In fact, we also I remember we supervised a student to do a project on tankering for a particular operations. This student had come to us for a master's program. He was from an African country and working for an airline, and the airline told him that please do a study to check about the tankering procedures and the tankering possibilities for optimum operations of that particular airline. There are many factors apart from the performance which affect the fleet planning. Let us look at these factors now very briefly. There could be factors related to marketing of the aircraft. There could be issues because an airline normally has an alliance with other airlines to remain competitive in the market. There could be economical and financial issues which create some constraints in fleet planning. There could be a push towards rationalizing the fleet. There also could be a requirement or a push to ensure commonality in the fleet, and that may affect fleet planning. And nowadays there is a huge trend towards leasing an aircraft as compared to owning an aircraft by an airline. So, let us look at these factors one by one. First, let us look at the marketing. So, first and the foremost important point that every airline has to look at is whom are we serving? Are we serving the leisure passengers? Are we serving the business class passengers? Are we serving a combination of both the passengers? So, therefore, the product which you are offering has to be carefully understood, right. Are you a scheduled airline or are you a chartered airline? If you are a scheduled airline, then you need to print your schedule in advance and people will sign up for that. But if you are a chartered airline, you will create schedules, identify airports, origin and destination. A destination normally is a fixed one, but origin could be changed because there are some airports in the vicinity of busy airports which are less expensive to operate, and charter airlines normally operate from such less expensive and less occupied, less busy airports. So, when we look at scheduled operation, that is the risk is borne by the airline. In chartered operations, the charter company normally does not own the aircraft, they take aircrafts on loan from the airline. It is their commercial risk. Okay. In scheduled, there is pre-published schedule as I mentioned, but charters are beyond the schedule. Then they are serving a wider variety of purpose. In scheduled operations, you are looking at multiple types of passengers with different types of services, different types of requirements. In the case of chartered aircraft, there is a single purpose: from this place to the destination at the least possible cost, fill the aircraft with people who have a specific purpose. It could be a charter because there is a football match or a cricket match and everybody has that particular intention, or it could be a destination like Goa. There are hundreds of chartered planes that land in Goa during the peak season, the winter season, the carnival time, the time December season, literally hundreds, and lots of flights come from Russia. Russia and Israel are two countries from where a lot of tourists come to Goa, and the demand can be so much that the scheduled airlines cannot handle it. So, these are handled by the chartered airlines. So, the underfloor of the scheduled operations are used for cargo, but in chartered airlines they are normally used for lavatories because the whole aircraft is filled up and the areas which are not reachable for other people are used for. Then there are some additional considerations. What are these? If you are looking at hub and spoke operation, then you need to offload and reload the passengers. So, you have to be very careful on what kind of aircraft you operate, small aircraft for the spokes and large aircraft for the hubs, so that you can optimize on both. Then location, okay, what kind of airspace class are you operating? Then is it controlled or open airspace? Generally it will be in the controlled airspace. And then there could be other objectives. There is one requirement called as a public service obligation, abbreviated as PSO. So, there are certain communities which are at remote locations. So, there the government is duty bound to supply certain transportation connectivity, even though it may not be commercially viable. For example, if you look at some communities in Alaska, they are given small aircraft fly with groceries and other important items, medicines, food, etc. There are some communities in Canada which are remotely located, where the government maintains a certain minimum level of service. It may not be affordable. These are small planes generally with 5-6 passengers. Some of them are combi planes which have some part is meant for passengers and some part is meant for cargo. You may have a situation of some sheep travelling along with the passengers in the hold behind. So, these obligations are there. So, you have to choose the aircraft carefully for such applications, and then sometimes you need to have a particular amount of fleet basically for national prestige. So, many of these considerations come in deciding the fleet of an aircraft. Alliances, as I mentioned, in a modern competitive scenario, to maintain the commercial viability, you may like to have an alliance with other airlines who can serve, because by joining an alliance such as a Star Alliance or One World Alliance, you increase the market reach. Okay. You are now able to reach much larger markets and you will also reduce your operating cost, but there are some difficulties. One issue is that if you are going for an alliance and if you have to go for joint purchasing, there could be delays, right. Then aircraft are normally configured to a specific airline. So, now if you are operating as a alliance, you may have to change the configuration to suit, correct. Similarly, the manufacturers may be unwilling to change the pricing policies, but there are also some benefits, right. Lower number of restrictions will be there if you are part of an alliance, higher revenue can be expected and the operational strategy can be improved if you are able to work with an alliance that suits both the airlines. Okay. Plus it can have better productivity. So, sometimes alliances will also impose certain constraints on the fleet that you have to choose. Then there could be economical and financial reasons which will directly affect the fleet planning. The choice of the aircraft actually it determines the financial success of the startups. It is very important. Some new airlines, in the anxiety of reducing their investment, they may start the operations with very old aircraft which are available at a throwaway price, but then they realize very soon that oh, these aircraft are consuming so much more fuel, their maintenance is so expensive, they are almost out of service, so the spare parts are difficult to achieve. So, sometimes just to reduce your capital investment, if you make a bad decision, you may end up in a financial soup. You have to be very careful to maintain the correct ratio of owned aircraft and leased aircraft, because owned aircraft means your money is upfront committed, leased aircraft means your money is committed only up to the lease. Okay. So, the investment that is needed is controlled by the ratio of or the proportion of the aircraft which are owned by you against the leased aircraft. Similarly, when you acquire an aircraft, there is a very important requirement for investor appraisal, so that the rate of ROI, return on investment, and the risk is both properly managed. Okay. Then there are some other procedures by which you can manage the debt to equity ratio, which is a very important KPI in airline operations. Some kind of off balance sheet leasing structures can be used for doing it. Okay. Then if you have more suppliers, then because of the ability to get some features, you have more leverage. But if you have a single supplier philosophy, then you may be controlled by the policies of that particular supplier. There is also a continuous push towards fleet rationalization. Basically, we would like to operate the minimum type of aircraft. Okay. So, we want to reduce the types of aircraft that we operate, because it gives you better operational efficiency and it lowers the operating cost. If you have multiple type of aircraft in your inventory, then you require qualified pilots, qualified maintenance engineers and crew members who can operate this aircraft. So, you may have a situation that you have a crew member, but they are idling because the aircraft is not available. If you have less number of aircraft, take the extreme case of some airlines who are interested in operating only one type of aircraft, such as the Southwest Airline. They have taken a policy that we will operate only one type of aircraft. So, they place order for large number of aircraft of a particular type. So, every aircraft can be operated by any crew member, both in the cockpit and in the cabin, and can be maintained by any maintenance engineer. So, they say that we have commonality to the extent that we do not go for any multiple type. Okay. But that is another extreme. Now, there is always a movement towards consolidation nowadays. What is this movement? So, if you have a consolidation, then you have a lower propensity to accept innovation. Okay. And also you have a lower propensity to implant advanced technology. So, there is a balance for a normal airline, there is a balance. You cannot oscillate between I will have different aircraft type for each market segment, optimized for each market segment, or I will have only one aircraft. There is a kind of a mix which has to be maintained. As I mentioned, there is an important issue regarding fleet commonality which also affects many a times the fleet planning decisions. So, fleet commonality helps in streamlining and simplifying the operations of an airline, both from the flying and the maintenance point of view. Okay. So, if you have identical cockpits and if you have identical operations procedures, then it allows mixed fleet flying, which I will explain to you in more detail little bit later. And commonality also improves the flight experience, right, because for everybody on board, when they fly, they know that we are using the same aircraft, same power plant, also helps many a times in maintenance. So, there is one very interesting scheme which Airbus had introduced called as the cross crew qualifications. The idea here is that any flight crew member qualified on an Airbus aircraft, they can fast track their qualification to another aircraft. Compared to this, if you look at other operators or other manufacturers, the time needed to change or to train a pilot from one aircraft type to that is much more, and therefore the training costs increase, right. So, for example, in Airbus they say that from A320 to 330 to 340 to 350 to 380 or any direction you can move very fast. So, a pilot who is operating Airbus E380 can then operate Airbus A320 because the differences in the cockpit are very few. So, here is an example about how the same type rating for a particular group of aircraft and time needed for training. So, if a pilot is qualified for Airbus A350, there are some A350 aircraft in the same type rating, and it will only need around 5 days to convert to A380 and vice versa, like that. You can see 5 days. So, this reduces the cost incurred by the airline in getting their crew members trained. Then you can also lead to operational commonality by design. Okay. So, what happens is you have, if you have an aircraft, if you have similar aircraft in your fleet, you have similar handling qualities. Okay. Your procedures are very similar when you fly. Then the process which is used for crew discipline for abnormal emergency is also same. So, during emergency, if you are used to a particular procedure and if it is same for all the aircraft, it becomes very easy because you will have less chance of making mistakes, and also you can share the task very easily. Okay. So, this benefits the airlines and pilots. Why? How does it benefit? It helps them to get licenses better. So, you can have things like same type rating is called as STR. So, a single license can be used as an endorsement for related aircraft sharing the same type certificate. So, the aircraft may be a bit different, but they have the same type rating. So, therefore, a pilot qualified on one is qualified to fly on any other pilot's aircraft. Then you have CTR, the common type rating. So, a single license endorsement for related aircraft having separate type certificates. So, although there are separate type certificates, but because of the commonality you can have a common type rating, or you can have, as I mentioned to you, cross crew qualification. So, the transition is shortened instead of full transition training to acquire a particular type rating. Another option is during operations there could be benefits. For example, single fleet flying or SSF, that means one pool of pilots flies a related aircraft under a single license endorsement, and there could be mixed fleet flying or MFF, where there is a one pool of pilots, they fly related aircraft that require separate license endorsements, but they fly together because of the differences. So, either licensing, training or operational, both areas you have improvement if you have commonality. Finally, let us look at the trend towards the leasing of aircraft rather than owning them. So, if you are a small carrier and if you lack the cash or the financial wherewithal to buy a few planes, then you can manage to enter the business and exit the business easily, relatively easily, by leasing them. Okay. So, for example, Air India has leased a lot of aircraft earlier from LFCO, and Jet Airways has leased a lot of aircraft from GCAS. These are two major leasing companies. Okay. Now, leasing also has various types. There is dry leasing. In dry leasing, you only take the physical aircraft. You have your own crew members and you have your own maintenance staff. Then you have wet leasing. In wet leasing, you take everything from the leaser. The pilots come with the aircraft, the crew members come with the aircraft, and even the maintenance is outsourced. You are only looking at operating the system. And then there is in between damp leasing, which is neither wet neither dry, it is damp. So, it could be a combination of these. So, there are two kinds of lease, the operating lease and the financial lease. Let us see the difference between these two. In the operating lease, the ownership of the asset, that is the aircraft, is retained by the lessor or the leasing company at the end of the lease. So, it is like the airline is simply borrowing the product, using it and returning it back. So, any risk to the value of the aircraft is borne by the lessor or the leasing company. Okay. In financial lease, on the other hand, in financial lease you are saying that we are going to take the aircraft from you on lease, use it, at the end of the lease we are going to buy it from you at an agreed upon sum. So, we are just delaying our financial commitment. Here the market risk is not borne by the lessor, it is the leasee or the company that airline that acquires the aircraft, they take the market risk. Okay. Now, operating costs and maintenance usually is the same in both the types. Okay. So, let us look at the difference between the two once again. So, we look at the factors like who owns the asset at the end of the lease and during the lease, who takes the risk and reward of the ownership, who is responsible for maintenance and repairs, usual length of the lease and the balance sheet, how it is treated. So, in finance lease, the leasing company owns the asset and the risk is taken care by or is taken by the lessee or by the airline which operates it. The maintenance and repair is done by the airline or the lessee. Usually the length of the lease is the entire or most of the useful span of the aircraft, and the aircraft appears in the balance sheet, okay, as an asset, because they are responsible for its depreciation. In an operating lease, very simple, the asset is owned by the leasing company, the risk and the reward is the leasing company, maintenance is done by the leasing company if the contract includes maintenance, or there may be some other company which will do it. The length of the lease is normally a part of the lifespan. If the aircraft life is 30 years, the operating lease could be for 2 years, and the balance sheet treatment is on or off balance sheet depending on accounting procedure. Normally, if you can always say that this is the operating expense which we have incurred, we do not own the asset, we do not have any issue about its depreciation. So, it is like, you know, when you run a taxi company and for example, Ola and Uber, you know, they do not own any assets. The cars are owned by the drivers or by the people whose cars are used. So, operations of a company like Uber and Ola can be considered as an operating lease, whereas people who take something on lease and then finally own it is the financial lease. Okay. The question that every airline faces is, should we upgrade or should we replace? So, for example, here is an example of an old aircraft replaced by a new aircraft. So, you have to look at various factors. You have to look at, okay, what is the cost of repair versus replacement? What is the effect of repair versus replacement on the future reliability of the aircraft? How critical is the safety affected? What is the fuel price going to be? Because generally old aircraft are going to have higher fuel consumptions and they may also not be noise compliant. So, all these factors affect the decision on whether you upgrade the aircraft or replace the aircraft. Thank you so much for your attention.